This experiment is for traverse wake test, which is basically looking at the pressure distribution behind a circular cylinder. In this experiment, there are two pitot tubes. One is a pitot-static tube, which is used to measure wind velocity. You can see in the test section of the wind tunnel, you can see the pitot tube facing against the flow of air. In the wind tunnel, the air is flowing from this side of the wind tunnel to this side. Behind the cylinder, you'll see a basic pitot tube with, let's see if I can get focus on it, with a digital display that gives you the distance that this pitot tube travels vertically in the test section. So the pressure difference for each pitot tube is on this control panel. In addition to the pitot tubes, there is also a single balance force transducer. This particular force transducer is oriented in order to measure the drag force of the cylinder while there's wind blowing in the test section. This single force transducer is connected to a display on the workbench, which is also connected to a DAQ system. This DAQ system will allow you to record all the data to a proprietary software that is for this wind tunnel. So double click on the software. You can make the screen bigger. What you're going to do is once you launch the software, you're going to go ahead and make sure that there are only check marks in the fields to which you want to record data. So we have right here a basic balance, so you're going to keep the basic balance. That is basically the drag force that will be recorded. You can uncheck all these other marks. These two, dB cell 1 and cell 2, those are the pressure differentials measured by the two manometers. These there's 4 gauges here. Excuse me. There are 4 gauges. You are going to only have gauge 1 checked. Gauge 1 is going to be the distance measured by the digital display for the pitot-static tube that's located behind the cylinder. You're going to uncheck manual angle. You're going to leave all these operating conditions checked because that is what's going to be used in order to convert the pressure measured by the basic pitot tube to velocity. And then you're going to uncheck all the airfoil characteristics because you are not using an airfoil for this experiment. In addition to the multi-channel pressure system, you're going to uncheck that. So that basically sets up the software to record. What you're going to do next is turn this red switch to power on. That will turn on the DAQ system. You should also hear the computer register the fact that you connected, turned on the system. So now the system you should see a little icon or a little bubble coming up down here that says USB status. VDOS USB device has been connected. As you recall from the prior experiment, to start the air flowing through the wind tunnel, you just press this green button. You'll hear it turn on, and then the black knob is used to control wind velocity. I'm going to leave it off during this video just due to the fact that it creates a lot of noise. Before you start anything, I want you to zero the 2 manometers. So all you need to do with that is to come and hold down the 0 button until it zeros. Do that for both manometers and also for the single component force transducer. If you come over to the system, to the software, you should see a thermometer next to the computer. Look at the temperature measured by the thermometer. Make sure to enter that temperature into the operating conditions. Right now it looks like it's about 22 degrees in here, Celsius. You come up here, press this icon. You should see that it says initiate communication with device. So you click on that, you should see the force come up from the force transducer, the pressure measured by the two manometers, as well as a digital display that should come on once you turn on the digital display, which gives you the distance that the pitot tube travels up and down the test section. So come over here as well, turn this on, and you should see a measurement for distance. Right now it's measuring 180.3 millimeters, and you should see that number up here under gauge 1. So now you're all set. What you're going to do is turn on the wind tunnel to a velocity of 25 meters per second. Once you do that, what you're going to do is move this move the pitot tube to move it almost to the top, but not quite. So just so the digital, so this actual device here is just slightly below the topmost position, so that you don't get the tube here caught up in between the top and the point at which it connects to the pitot tube. What you're going to do is, while the wind is on, while the airflow is on, you're going to move this pitot tube. You see that I'm actually moving it down vertically. You're going to move it down to a point that these two manometers are at about an equal value. Now, one manometer, which is the one on this digital manometer on the bottom, is connected to the pitot tube that will move vertically up and down. The other pitot tube here is connected to the top manometer. That pitot tube is at a fixed position forward of the cylinder in order to measure the velocity. So this value should be relatively constant during the whole experiment. This digital manometer is measuring the pressure difference across the pitot tube, the pitot tube here, which is moving vertically up and down behind the wake that's created by the airflow over the cylinder. So what's going to happen is that you're going to move it from a top position, move it down until you start just getting into the wake. That should be a point to when this velocity starts to change to a point that it's just slightly below this, this pressure is slightly below this pressure. Try to position the pitot tube such that these two pressures are approximately equal. Then what you're going to do is you're going to come up here after it's positioned, and you're going to zero. You can see right here, see if I can focus in. This button right here is meant to zero the digital display. So press it in. You should need to hold it for a few seconds, and it should zero. So right now it's at a zero position. Once you do that, you're going to come over to the software, and you're going to click on Record Data. So you would click on this icon, and then you'll record the first position. And then what you're going to do is come back over here, move this down 10 millimeters until the digital display displays approximately 10 millimeters. Doesn't have to be exactly, so right now I got it at about 10.18 millimeters. You should start to see this pressure change. You should see that pressure start to decrease. Come over here, click on the pencil icon. Try to focus in again. And you're going to keep doing that every 10 millimeters. So then you'll come down to 20 millimeters. Do that and then keep progressing. As you do that, you're going to see the pressure displayed at this manometer decrease, and then it'll start to increase again. Keep recording every 10 millimeters until this manometer displays a pressure that's approximately equal to that manometer again. It should be somewhere between 180 and 200 millimeters. Once you're done, you're going to go ahead, after you take your last measurement, click on HTML, and then save, name a file to save your data to. I'll just call it try. Save it to a desktop. Right, and then up should come all of your measurements. You can see here the pressure. Right there is my measurements for the distance and so forth. You should have up to about 180 to 200 millimeters worth of measurements. And then save it to your flash drive and copy it over to your computer to process the data. This concludes the instructional video for a traverse weight test of a circular cylinder.